Welcome to one of the world's most advanced semiconductor facilities, producing millions of bright LEDs every day. These microscopic light-emitting diodes power everything from city streetlights to giant stadium displays. Inside this ultra-clean facility, pressure and air quality are strictly controlled to protect delicate electronics. Automated monorail systems transport delicate raw materials seamlessly across massive dust-free work halls. The process begins with synthetic sapphire cylinders, known for their exceptional crystal purity and clarity. Technicians perform strict quality checks on every sapphire boule to ensure zero structural defects exist. High-precision diamond saws slice the sapphire cylinders into paper-thin, perfectly circular raw wafers. Chemical polishing systems clean each wafer surface until it reaches an absolute mirror-like smoothness. Optical laser scanners verify the thickness and surface uniformity of each polished wafer, down to nanometers. Polished wafers are loaded into ultra-clean vacuum-sealed transfer boxes for transport to chemical processing. Technicians in protective bunny suits load the pristine wafers into specialized chemical cleaning baths. Deionized water rinses away all micro dust particles before thermal baking completely dries each substrate. Clean wafers enter the high-temperature chemical vapor reactor, where semiconductor layers will grow. Under intense heat, gallium and nitrogen gases deposit atomic layers onto the heated wafer surfaces. These thin semiconductor layers form the quantum wells responsible for emitting bright visible light. Specialized diopants are introduced to establish positive and negative electrical junctions across the wafer. High-vacuum sputtering machines apply ultra-thin metallic contact layers to power the future diodes. Photolithography equipment coats the wafer with light-sensitive resin to print intricate circuit designs. Ultraviolet light projects precision circuit patterns directly onto the photoresist-coated semiconductor. Chemical etching baths strip away excess metal, leaving thousands of distinct electrical contact pads behind. Automated laser scribing tools cut microscopic grid patterns across the multi-layered semiconductor wafer. A rubber roller applies gentle pressure, flexing the wafer to snap it into thousands of individual microchips. Robotic vacuum needles pick up tested microchips and organize them onto sticky blue transfer tape rolls. Continuous stamped metal lead frames pass through high-speed automated dispensing units below. Automated place heads bond each microchip firmly into the reflective copper lead frame cavities. High-speed wire bonding heads attach microscopic gold wire connections between chip and frame. High-speed cameras verify that every single gold wire connection meets precise tensile strength standards. Liquid silicone mixed with yellow phosphor powder is injected precisely over the mounted semiconductor chips. The yellow phosphor absorbs raw blue light and converts it into pleasant white light for general illumination. Conveyor lines move the filled lead frames into long thermal ovens to cure and harden the silicone gel. Automated probes touch every terminal, pulsing electricity to test brightness, color, and power draw. Precision punch dies cut individual finished LED packages out of the continuous copper lead frame strips. High-speed optical sorters categorize completed LEDs into distinct bins according to exact color temperature. Robotic arms package sorted LED components into anti-static carrier tape for automated circuit board assembly. Automated taping machines seal protective cover tape over carrier reels to shield components during transport. Finished component reels receive barcode labels and are packed into sealed moisture-proof aluminum bags. Barcoded boxes move onto automated packaging lines, where robotic arms stack them neatly onto wooden pallets. Warehouse forklifts load palletized shipments onto freight trucks bound for global electronics factories. These tiny components will soon illuminate homes, vehicles, and electronics across the globe. Thank you for watching. Subscribe for more factory documentaries every week.